Christopher Bach was a Danish theoretical physicist who co-authored the 1987 academic paper that coined the term self-organized criticality, life and work. After receiving his Ph.D. from the Technical University of Denmark in 1974, Bach worked at Brookhaven National Laboratory. He specialized in phase transitions, such as those occurring when an insulator suddenly becomes a conductor or when water freezes. In that context, he also did important work on complicated spatially modulated structures in solids. This research led him to the more general question of how organization emerges from disorder. In 1987, he and two postdoctoral researchers, Chao Tang and Kurt Wiesenfeld, published an article in Physical Review Letters setting a new concept they called self-organized criticality, the first discovered example of a dynamical system displaying such self-organized criticality. The Bach-Tang-Wiesenfeld sandpile model was named after them. Faced with many skeptics, Bach pursued the implications of his theory at a number of institutions, including the Brookhaven National Laboratory, the Santa Fe Institute, the Niels Bohr Institute in Copenhagen, and Imperial College London, where he became a professor in 2000. In 1996, he took his ideas to a broader audience with his ambitiously entitled book, How Nature Works. In 2001, Bach learned that he had myelodysplastic syndrome and died from it the following year. Bach is survived by his second wife, Maya Paczewski, a fellow physicist at Imperial College with whom he has co-authored papers, and his 4 children. Others about Bach. He was the most American of Danes, said Predrag Svitanovich. Danes eschew confrontation, but he was arrogant and loved to fight with his colleagues in academia. We all have stories of how we first met him, usually remembered by some outrageous statement or insult. A sample of Professor Bach's statements at conferences. After a young and hopeful researcher had presented his recent work, Professor Bach stood up and almost screamed, "Perhaps I'm the only crazy person in here, but I understand zero of what you said." Another young scholar was met with the gratifying question, "Excuse me, but what is actually non-trivial about what you did?" Chao Tang mentions his mentor's irreverent style. He certainly was one of the most original people in science, and also one of the very few who truly doesn't care what other people think about what he is doing. He was sort of on his own. Selected publications. 1982, Commensurate Phases, Incommensurate Phases, and The Devil's Staircase, in Reports on Progress in Physics, Volume 45, pp. 587-629, DOI 10.1088-0034-4885-45/6/001. 1987, Self-Organized Criticality. An Explanation of 1F Noise, with Chao Tang and Kurt Wiesenfeld, in Physical Review Letters, Volume 59, pp. 381-384, DOI 10.1103, Fazrevlet 59.381. 1996, How Nature Works. The Science of Self-Organized Criticality, New York. Copernicus. ISBN 0-387-94791-4. 1983. Doing Physics with Microcomputers. An ordinary personal computer can be used to do large-scale calculations in physics at a great savings in cost and added personal convenience for the researcher. In Physics Today, December 1983, pp. 25-28, http://dx.doi.org/10.1063/1.2915383